My name is EMMANUEL OFOSU. I'm a final year physics with electronics student. My interests are centered around quantum computing, space exploration, electronics, and physics in general. These days, my curiosity is centered around quantum computing and how Africa, for instance, can use quantum computers to solve problems pertaining to new drug discovery, making route optimizations faster and all that. And then I'm also interested in how we can apply quantum computing in space exploration. One aspect of quantum computing that is receiving a lot of attention these days is about communication, being able to send information through a longer distance without interruption, without somebody being able to hack. Yes, so for instance, in quantum computing, we have something called quantum key distribution, and it's centered around you sending information to longer distances. Let's say when humanity is able to explore planets like Mars, and then maybe we have a habitat on the moon, quantum computing will give us that kind of secured communication to be able to interact with astronauts and then the ground base to be able to exchange information, beam scientific data from or their scientific findings from the moon or Mars and send it back home without any interruption at the speed of light. And that is what makes quantum computing exciting for me, and then the future it holds for Africa in general. So my final year project is to design a microbial fuel cell coupled microbial electrolysis cell. Now let me break it down. So the world is going green. We want to reduce our impact on climate action. Therefore, there is the need for us to produce energy at a scale that is not harmful to the environment. And one of those promising energy that we can harvest is hydrogen. And hydrogen mostly is obtained through a chemical process called electrolysis. If you remember your chemistry word, it's called electrolysis. But then the electrolysis that we use to produce hydrogen currently is still based on fossil fuels. Fossil fuels are the energies that are causing harm to the environment. So the idea is to have a setup that produces hydrogen like in an organic manner, right? And one of those setups is called the microbial electrolysis cell. So microbial electrolysis cell is mainly using biological actions to produce hydrogen. But then most of the biological microbial fuel cells, microbial electrolysis cells that we have around are still based on the national grid, which is mostly fossil fuels. So the idea is to have a setup that will provide power to the setup that is producing hydrogen. And one of those promising setups, again, is microbial fuel cell. So I'm making a setup for producing hydrogen, and then I'm making a setup for producing the power that will be fed into the setup producing hydrogen. So that is why I said microbial fuel cell coupled microbial electrolysis cell. Now, where does quantum computing come in? So mostly if you have the setup around for a very long time, you realize that the amount of power generated from the setup, when I talk about power, I'm talking about multiplying the voltage by the current. You realize that the power will be reducing with time. And then quantum computing has proven to be a way for us to get to know the extent at which something will happen, or the extent at which something will go. And over here, I'm using quantum computing to be able to estimate how long the setup will last before the power starts reducing, and then I can discard it and then make up another one. So that is what I worked on for my qubit by qubit final year project, which is different from my KNUST final year project. So my KNUST final year project is producing the electrolysis cell and the fuel cell, and then my qubit by qubit, which is a quantum computing 1 year long program. That is where I applied my knowledge in quantum computing to be able to optimize the design of the microbial fuel cell coupled microbial electrolysis cell. So I worked on a paper I submitted to the people, so you can come and look at it. Okay. So in this setup, you can see a microbial fuel cell. Basically, this part of the microbial fuel cell is the anode part, and then this is the cathode part. To the uninitiated, this part means it's positive, and this part means it's negative. But what this microbial fuel cell is basically doing is producing electrons, and then we are transferring that electron to maybe a load, which is a light bulb or something. But this setup contains this red band, which is called the exchange membrane. That is where excess cations or anions are being transferred from this particular setup to this part. And then this exchange membrane is one of the ongoing researches that is we are trying to optimize, because we have realized that the higher the effectiveness of this exchange membrane, the higher the effectiveness of the whole microbial fuel cell. Yes. So as a budding young researcher, or somebody who is curious about science in particular, most of the time I use my time on social media to explore these motifs. Especially on LinkedIn, I reach out to famous scientists in the physics world, quantum computing world, and then learn about them from their posts, their articles, their personal blogs. And then for Twitter, for instance, I mostly go there because you find PhD opportunities, undergraduate opportunities, internships being posted by the researchers themselves, not a third person. And that is what I think makes social media in this Gen Z generation very, very absolute, if you know how to go about it. Africa, for instance, a lot of statistics shows that the future of the world is going to be in Africa. What do I mean by that? When you check statistics, by 2050, a lot of our population will be youth, which means that there are a lot of opportunities for the youth, and then there are a lot of opportunities in terms of research and those who are curious. Particularly research in quantum computing can help in safer communication, like I said. Imagine being in Africa or being in Ghana, and then maybe somebody will hack the electricity company of Ghana, or maybe somebody will hack our energy system. If we transition from this classical computing side to quantum computing, hopefully maybe by the next decade or maybe the next century, it means that Africa, for instance, this after thing that we want to make collaboration with countries and trade goods and services, it will be safer in terms of our finances. We'll be able to send money safely. We'll be able to have the quantum internet where information is sent faster even than the current system that is using fiber optics and all that. So among all this, if students and scientists hop on the quantum computing bandwagon and then expand it, this is something that we can own. This is something that we can own and partake in. And fortunately for us, a lot of people in Africa are already in the field already. I can talk about so many people in Ghana, in South Africa. We have One Quantum Ghana, chapters in Ghana, Cote d'Ivoire, and all those places. So I think quantum computing has a future in the world, and then has a brighter future in Africa, for instance. And that is what makes me proud to be a quantum computing enthusiast.